Our basic idea is that we are looking at AI applications. AI is artificial intelligence. And then we're looking at the topology of our future networks, the 5G networks. And in 5G networks, for the first time, we will be having a distribution of compute resources. So it's not back-end, dumb copper, front-end, but we'll be having places in between where we can do manipulation, especially near the edge. And then we were asking ourselves, could we distribute or modularize AI applications so that they map optimally onto this new compute structure? So on the first use case we came up with is urban traffic flow, so where we took the optimization issue down to a local level. We do it crossroad by crossroad, and then on a global scale this needs to be harmonized. That's basically, in an abstract way, the idea. And in a concrete way, we were doing this in Berlin at the Ernst-Reuter-Platz, where we have a real deployment of traffic sensors, 5 cameras, which are capturing constantly the pixel stream. We were doing a measuring campaign over several weeks there. And then our AI started kicking in on 2 levels. First level is just the object recognition. This is middle of the road, everyone's doing this, so we just applied a known solution. But then comes the clever bit, and this is our intellectual property, really. This is understanding the objects we have seen as a traffic situation. So if you have a situation then, and you understand what it is, then you can try to optimize the program of the traffic lights. And that's what this really is about. So we did it's called in the business reinforcement learning. It's optimization procedure, really, where we play in the computer environment, a simulation tool. We play around with the traffic lights, and then we look what does it do to the traffic flows. And if the overall picture is better, then you get a reward in the computer in a mathematical way. And if it's worse, you have to pay a penalty. And this converges onto the optimum. We did that, and we found, and this was confirmed by a friend of mine, he's professor in the Traffic Research Institute in Berlin, that we can improve the throughput quality of the crossroad by 20%, which is a huge number. And for us, it's important that this is done locally in the edge, and the project is called 5G Reflex because it plays into the humans and higher mammals, so that you have reflexes and you have situations where you do not to engage your brain. So this is done locally in a reflexive way. And for us, this means in a traffic environment that you can detect a traffic situation, and then very reflexively and in an agile way you react to that and optimize the flow locally. And then in a second step you have to look at your neighbors, what are they doing, and what's the systemic optimum, so to speak.